Hello friends, it's time to practice sums from the chapter Areas Related to Circles. So I have 15 MCQs for us to practice, and before we begin, let's quickly revisit the formulas related to circles, sectors and segment. Area of a circle is given by pi r square and circumference of a circle is 2 pi r. Pi is a constant and we will be using the value as 22 by 7, or in decimal it is given taken up as 3.14. Now let's see about sector. Sector is a portion of a circle that is enclosed by two radii and an arc. So here the circle's radius is r and the angle made at the center by the two radii considered is theta. There are actually two sectors. One is the minor sector, which is indicated by pink colored region, and the remaining portion of the circle, which is white in color, is the major sector. So what is the area of this pink portion, that is minor sector? Area of the minor sector is given as theta by 360 into pi r square. Theta by 360 into pi r square. We can consider the entire circle to be a sector where the angle at the center is 360 degrees. If we come around the center point, the angle around the center is 360 degrees. So when the angle at the center is 360 degrees, the area of that shape, that is the circle, is pi r square. So if we want only the area of this shaded portion where the angle at the center is theta, we can derive the formula as theta by 360 into pi r square. So when the central angle is theta, the area of that sector is theta by 360 multiplied by the area of the circle itself. If we want to know the area of the major sector, this white portion, we have to subtract the area of the minor sector from the area of the circle. So let's move on to length of an arc. If we have a sector as shown in the figure and we are required to find the length of the arc that is a part of this sector, assuming we know the radius r and the central angle theta, the formula is theta by 360 into 2 pi r. Theta by 360 into 2 pi r. Same manner as we saw in the previous slide, when the central angle is 360 degrees for the entire circle, what is the circumference? It is 2 pi r. So if the central angle is just theta, what will be the circumference or the part of this arc's length? It will be theta by 360 into 2 pi r. So the length of this arc is given as theta by 360 into the circumference of the full circle 2 pi r. So we have seen how to find the area of a sector and length of the arc. Let's move on to segment. So in a circle, when there is a chord AB, then the circle is divided into two segments. Minor segment shown in blue color and major segment shown in white color here. So segment is the area enclosed by the chord, here it is AB, and the arc of the circle APB. Now, how to find the area of this segment, this blue colored region? We have to compute the area of the sector OAPB. Formula is theta by 360 into pi r square. Then we take away the area of this triangle OAB from that. So area of the minor segment APB, that is blue in color, is area of the sector OAPB minus area of the triangle OAB. So once we find the area of the minor segment, we can always find the area of the major segment by subtracting the area of the minor segment from the entire area of the circle. Whenever we say sector or segment, it refers to the minor segment and minor sector unless it is explicitly specified as major segment or major sector. By default, the word segment and sector refers to only the minor segment and minor sector. So now let's begin practicing the MCQs from this chapter. If the difference between the circumference and the radius of a circle is 37 centimeter, pi is 22/7, the circumference in centimeter of the circle is. So it's given that the circumference and the radius of the circle's difference is 37 centimeter. So C minus R is 37. C stands for circumference. Formula is 2 pi R minus R. It is given as 37. So let's solve for R from this. R into 2 pi minus 1 will be 37. So R will be 2 into 22/7 minus 1 equal to 37. So R into 44/7 minus 1 is 37. So R into 44 minus 7/7 will be 37. So we will be getting R as 7 centimeter. Immediately don't mark the answer as option D 7 because the question is what is the circumference of the circle. So we need to find 2 pi r, which is 2 into 22/7 into 7. So it will be 44 centimeter. Option B 44 is the correct answer. Let's move on to the second sum. The perimeter of a semicircular protractor whose radius r is pi plus 2r, pi plus r, pi r plus 2r. Few of us might immediately mark the answer as option C, pi plus r, but that is not the correct answer. It's not just a semicircle, it is semicircular protractor. So let's have a rough diagram to understand it better. We have a semicircular protractor with radius as r. So if you see, there are two portions. One is the semicircular arc and then one straight line which is the diameter. So what will be the total perimeter? It will be this arc's length plus the diameter. What is the length of this arc? It is pi r because for the entire circle it will be 2 pi r. We have only half of it. So it will be pi r. So this arc's length is pi r and then we have one entire diameter. R plus r will be 2r. So the total perimeter is pi r plus 2r. So option D is the correct answer. Third sum. If the circumference of a circle increases from 2 pi to 4 pi, then its area is dash the original area. So let's consider two circles with circumference as 2 pi and 4 pi. Then we'll find the ratio between their areas. So this circle, the circumference, let it be 2 pi, and the bigger circle circumference is 4 pi. Let's find the ratio of the area of this circle to the bigger circle. Let the radius of the smaller circle be denoted by r and radius of the bigger circle be capital R. Let the area be small a and capital A. So let's find A by A. So A by A will be pi r square divided by pi r square, which is radius square by the second radius square. Now we know that the circumference is 2 pi. So 2 pi r is 2 pi for this circle. So r will be 1. And for this circle, 2 pi r is 4 pi. So the radius of this circle will be 2. Hence r square by r square will be 1 square divided by 2 square, which is 1 by 4. So the bigger area is 4 times the smaller area. Hence option D is the correct answer. Question number 4. The number of revolutions made by a circular wheel of radius 0.7 meter in rolling a distance of 176 meter is. Options are 22, 24, 75 and 40. For a circular wheel, the distance covered by the wheel in one revolution is equal to the circumference of the wheel. So if we find the circumference of the wheel, we can determine the distance traveled by it in one revolution. Here the radius of the wheel is given as 0.7 meter. So first let's find the circumference of the wheel. So circumference is 2 pi r, 2 into 22 by 7 into 0.7. So it will be 44 into 0.1, so 4.4 meter. So this is the circumference of the wheel. So for one revolution, the wheel will travel a distance of 4.4 meter. 4.4 meter is the distance covered in one revolution. So for 176 meters, how many revolutions will it make? It will be 176 by 4.4. We just have to cross multiply and find. So if n is the number of revolutions, it is equal to 176 divided by 4.4. This will be 11 tables, 0.4 times, 16 times. So 40 is the answer. Number of revolutions is 40. D 40 is the correct answer. Question number 5. In a circle of diameter 42 centimeter, if an arc subtends an angle of 60 degrees at the center where pi is 22 by 7, then the length of the arc is. So the circle's diameter is 42. Radius will be 42 by 2, which is 21 centimeter. arc subtends an angle of 60 degrees. So center angle is 60 degrees. We need to find the length of this arc. What is the formula for length of the arc? It's theta by 360 into 2 pi r. Theta is 60 by 360 into 2 pi r. 6 times is 360. 7 threes are 21. 3 twos are 6. So 22 centimeter is the length of the arc. Option C is the correct answer. Next sum. Question number 6. Area of a sector of a circle is 1/6 to the area of a circle. Find the degree measure of its minor arc. So here it's given that the area of the sector is 1/6 of the area of the circle. Area of the sector is 1/6 into area of the circle. What is the formula for area of the sector? Theta by 360 into pi r square. 1/6 of area of the circle is pi r square. So pi r square and pi r square gets cancelled. We need to find only theta, which is 360 by 6. So 60 degrees. Option B, 60 is the correct answer. Question number 7. The circumference of a circle is 100 centimeter. The side of a square inscribed in a circle is. So let's draw the diagram first. We have a circle and a square is inscribed inside a circle. Let this be the center of the circle. We are given that the circumference of the circle is 100 centimeter. We need to find the side of the square. When a square is inscribed inside a circle, we can see that the diagonal of the square is equal to the diameter of the circle. So 2 pi r, that is the circumference of the circle, is given as 100 centimeter. So the radius will be 100 by 2 pi. Diameter will be 2 into the radius. So it will be 2 into 100 by 2 pi, which is 100 by pi. Now this diameter is equal to the diagonal of the square. So diagonal is equal to 100 by pi. If the side of the square is a, we know that the diagonal is given by a root 2. So a root 2 is 100 by pi. Side of the square a will be 100 by root 2 pi. Normally we'll rationalize when we get such an answer with a square root in the denominator. For rationalizing, we multiply by root 2 in the numerator and denominator. So we get 100 root 2 divided by root 2 into root 2 will give us 2 pi. So it is 50 root 2 divided by pi. Side of the square is 50 root 2 by pi centimeter. Option C is the correct answer. Question number 8. In the figure given below, ABCD is a square of side 14 centimeter. EFGH are the midpoints of the sides AB, BC, CD and DA respectively. The area of the shaded portion is. So let's divide this area, that is the shaded portion, into two parts. First one on the top and second one on the bottom. Now first part is a semicircle. So area of the first part will be area of this semicircle. It's given that square side is 14 centimeter. The entire length is 14 centimeters. So diameter of this semicircle is also 14. So the radius will be 7 centimeter. Area of this black first portion, area of the semicircle, pi r square by 2, which is pi into 7 square by 2, 49 by 2 pi. This is the area of the dark portion marked as 1, that is area of this semicircle. Now let's go to the portion marked as number 2 here. This shaded portion, we can see that we can find the area of this shaded portion by subtracting the area of these two quadrants from the area of the rectangle HFCD. So area of portion 2 is nothing but area of rectangle HFCD minus area of the two quadrants. These are the two quadrants drawn with D and C as the center respectively. Now when we add the area of the two quadrants, we will get the area of the semicircle, right? Two quadrants will together form a semicircle. So we can actually replace this with area of semicircle. Radius is same for both the quadrants here because G is the midpoint. Here also it is 7 centimeter. Here also it is 7 centimeter. So two quadrants with radius 7 centimeter will form a semicircle like in this figure, and the radius will be 7 centimeter. So area of the triangle HFCD is, length will be 14 and height will be, or the breadth will be half of the side, so 7. So it is length 14 into breadth 7 minus area of the semicircle is again pi r square by 2. 14 into 7 will be 98 minus pi r square by 2, r is 7, so 49 pi by 2. For the area of the shaded portion, we need to add 1 and 2's area. So 49 pi by 2 plus 98 minus 49 pi by 2. Both will get cancelled and we will have only 98. So answer is option C, 98 centimeter square. Question number 9. Given below is the picture of the Olympic rings made by taking 5 congruent circles of radius 1 centimeter each, intersecting in such a way that the chord formed by joining the points of intersection of two circles is of length 1 centimeter. Total area of all the dotted regions, assuming the thickness of the rings to be negligible, is. So we need to find the area of the dotted regions. There are 1, 2, 3, 4 dotted regions and we need to find the total area. Let's first number the circles. There are 5 circles. Let's consider circle number 1 and 4 separately. 1. Let this be the circle number 1 indicated here. There is a chord AB. The length of the chord is also 1 centimeter. The radius of the circle is also 1 centimeter. Now here, this is a minor segment. We can find the area of this minor segment. Similarly, in circle number 4, let this be the circle number 4. The same chord AB forms a minor segment. I'm shading it in green region. Here again, the radius is 1 and the length of the chord is also 1. So we can separately find the area of this minor segment as well. So the green region is the segment in circle number 4, and we have the segment in circle number 4, or sorry, the segment in circle number 1 indicated with a blue region. So in one intersection we have two segments. Similarly here, in this intersection between circle number 2 and 4, there will be two segments. And in this intersection again, two more segments. Here again, two more segments. So for each intersection, there are two segments where the length of the chord is 1. The radius of the circles are also 1. So totally in these dotted regions, we have 8 segments. So we just have to find the area of these 8 segments. All the 8 segments, the radii is 1 and the length of the chord is also 1. So what is the area of one segment? It will be area of this sector OAPB. Area of sector OAPB minus area of triangle OAB. So let's find the area of this blue region in circle number 1. Area of sector OAPB is the central angle. We can see that this is an equilateral triangle because the radii of the circle is 1 and the chord's length is also 1. So all three angles in an equilateral triangle will be equal to 60 degrees. So the central angle is 60. Area of the sector will be theta by 360 into pi r square. Here r is 1, so 1 square. Minus area of triangle OAB. Equilateral triangle, the area is given as root 3 by 4a square, where a is 1 here. A is nothing but the side of the triangle and it is 1. So it will be 60 is 6 times. So pi by 6 minus root 3 by 4. This is the area of one segment. So area of the dotted regions will be, there are totally 8 segments as we saw before. So you have to multiply it with 8. 8 into pi by 6 minus root 3 by 4. Let's go to the options and check the correct one. Option D, 8 into pi by 6 minus root 3 by 4 centimeter square is the correct answer. Now let's move on to the next sum. Question number 10. A cow is tied with a rope of length 14 meter at the corner of a rectangular field of dimensions 20 meter into 16 meter. Then the area of the field in which the cow can graze is 154 square meter, 156 square meter, 158 square meter, or 160 square meter. So there is a rectangular field given by ABCD, and the rope is fixed at the corner A. Length of the rope is 14 meter. So when the rope is fixed here, the cow will be able to move along the arc FEG or within the arc FEG. So the cow can graze this portion, which is nothing but a sector with the central angle will be 90 degrees because area in a rectangle is 90 degrees. Radius is the length of the rope 14 meters. So we need to find the area of this sector. What is the area formula? Theta by 360 into pi r square. Theta is 90 degree by 360 into pi. R is the length of the rope, which is 14. Pi, we can take it as 22 by 7. Ninety-fours are 360. So if we solve, we get answer as 154 square meter. So option A, 154 square meter is the area of the sector, which is the same as the area of the field in which the cow can graze. Next question is a case study. A brooch is a small piece of jewelry which has a pin at the back so it can be fastened on a dress, blouse, or coat. Designs of some brooches are shown below. Observe them carefully. Design A. Brooch A is made with silver wire in the form of a circle with diameter 28 mm. The wire is used for making 4 diameters which divide the circle into 8 equal parts. So this is the design A. Design B. Brooch B is made of two colors, gold and silver. Outer part is made with gold. The circumference of the silver part is 44 mm and the gold part is 3 mm wide everywhere. Now let's see the questions asked based on these brooch designs. Refer to design A. Question number 11. The total length of silver wire required is 180, 200, 250 or 280. So in this design, there is a circular brooch and there are 4 diameters running across. So the length of the silver wire will be the circumference of the circle 2 pi r plus the 4 diameters, that is the straight lines that are running across. So we can simplify this. 2r can be written as diameter d plus 4d. We can pull out the diameter as common, pi plus 4. The diameter is given as 28 millimeter. So 28 into 22 by 7 plus 4, 28 into 22 plus 28 by 7, which is 28 into 22 plus 28 will give us 50 by 7. 7 fours are 28, so it will be 200 mm. So option B, 200 millimeter is the correct answer. Moving on to the next question. Refer to design A. The area of each sector of the brooch is. So it is given that the circular design is divided into 8 equal parts. So there are 8 equal sectors and we need to find the area of each sector. Since they are equal parts, we can simply divide the area of the circle by 8. So pi r square by 8 will be the area of each sector. So diameter was given as 28 millimeter. So radius will be half of it, 14 millimeter. Pi into 14 square by 8. 22 by 7 into 14 into 14 divided by 8. It will be 77 square millimeter. So the area of each of this sector is 77 square millimeter. Option C is the correct answer. Next question. Question number 13. Question number 13. Refer to design B. The circumference of outer part, that is golden part, is. In design B, the inner part is made of silver and the outer ring is made of gold. It is also given that the circumference of the inner portion is 44 millimeter. So circumference of inner circle is 44 millimeter. So let's first find the radius of the inner circle. 2 pi r is 44. Solving this, we will get r as 44 by 2 pi and it will be 7 millimeter. So the radius of the inner part is 7 millimeter. In the question, it is clearly given that the width of this golden band is 3 millimeter. So the radius of the outer circle will be 7 plus 3. So the bigger radius will be 7 plus 3, 10 millimeter. Now we need to find the circumference of the outer part, which will be 2 pi r, where radius is 10 millimeter. Since the answer is given in decimals, let's use the value of pi as 3.14 into radius is 10. So this will give us 62.8 millimeter. So the closest would be option D. Answer is 62.86 millimeter. Let's go on to the next sum. This again is from design B. The difference of areas of golden and silver parts is. So we need to find the area of this band between the two concentric circles. We already have found out the radius of the outer and the inner rings. The outer radius is 10 and the inner radius is 7. So the area of this band between the two circles will be area of the outer circle minus area of the inner circle. We can take out pi as common, r square minus r square, which is pi into outer circle is radius is 10, so 10 square is 100 and 7 square is 49, so it will be 51 pi. So answer is option C, 51 pi. Last question, question number 15. A boy is playing with brooch B. He makes revolution with it along its edge. How many complete revolutions must it take to cover 80 pi distance? So we have already seen in sums related to wheel that in one revolution the distance covered will be the circumference, that is 2 pi r. So how many revolutions must it make to cover a distance of 80 pi? So how can you find this unknown number of revolutions? N is equal to 80 pi by 2 pi r. This can be simplified as 40. So it will be 40 divided by r. R is the radius of the outer circle, which we know is 10 millimeter. So 40 by 10 will be 4. Number of revolutions to complete a distance of 80 pi will be 4. Option C, 4 is the correct answer. That's the end of this video, my friends. Thanks for watching. To practice sums from other chapters, kindly visit our channel and check the playlist. Do not forget to like, share, and comment on our videos. If you are yet to subscribe, do subscribe and press the bell icon to receive updates as and when new videos are uploaded. Thank you and keep practicing.